Dear students, all of you welcome to Vidyayana classes. Today we will discuss some expected board questions on continuity. First question, find the value of P and Q for which the function fx defined by is continuous at x equal to pi by 2. The function is continuous at x equal to pi by 2 means the left hand limit of the function at x equal to pi by 2 is equal to right hand limit of the function at x equal to pi by 2 is equal to value of the function at x equal to pi by 2. Clear? Answer given fx is continuous at x equal to pi by 2. Which implies this limit x tends to pi by 2 minus of fx. X tends to pi by 2 minus x less than pi by 2. The function is defined by 1 minus sin qx divided by 3 cos square x is equal to right hand limit at x equal to pi by 2. X greater than pi by 2. The function is defined by q into 1 minus sin x divided by pi minus 2x its whole square is equal to value of the function at x equal to pi by 2. That means f of pi by 2 which is equal to p. Limit x tends to pi by 2 minus aq minus bq 1 minus sin x into 1 plus sin x plus sin square x. Clear? Position mark 3 into cos square x is equal to 1 minus sin x into 1 plus sin x which is equal to limit x tends to pi by 2 plus q into 1 minus sin x can be written as 1 minus cos pi by 2 minus x. Cos of 90 minus theta is equal to sin theta whole divided by pi minus 2x is square which is equal to f of pi by 2. F of pi by 2 is equal to p. Clear? The value of the function at x equal to pi by 2 is p. 1 minus sin x, 1 minus cancel which is equal to limit pi by 2 minus 1 plus sin x plus sin square x divided by 3 into 1 plus sin x which is equal to limit x tends to pi by 2 plus limit x tends to pi by 2 plus 1 minus cos theta is equal to 2 sin square theta by 2 q into 2 sin square theta by 2 that means pi by 2 minus x by 2 and the denominator 2 taking common it is pi by 2 minus x its square. Clear? 2 into pi by 2 that is equal to pi, 2 into x that is 2x is equal to p. Clear? Which implies this x tends to pi by 2 the limit of this 1 sin 90 plus sin 90 and its square, that is equal to 3 1 plus 1 square divided by 3 1 plus 1 which is equal to 2 cube. Sin limit extends to pi by 2 plus sin pi by 2 minus x by 2 whole divided by pi by 2 minus x by 2 whole square. Sin pi by 2 minus by 2 it whole square divided by pi by 2 minus x whole square into 2 square is equal to 4 and by 2 into 4. Clear? 2 square, that is 4 into 4 cancel. 2 square is equal to 4 is equal to which implies as 3 by 3 into 2 cube sin theta by theta is equal to 1 divided by 16 is equal to p. 3 cancel, it is 8 which is same as 1 by 2 is equal to 2 cube into 1 by 8 is equal to q by this is equal to p. Q by 8. Therefore, P is equal to half and Q is equal to 8 by 2, that is equal to 4. Clear? The value of P is half and the value of Q is 4. Clear? Okay, next question. The value of lambda so that the function fx defined by is continuous at x equal to pi is dash. What is the value of lambda? Given f is continuous at x equal to pi implies this left hand limit at x equal to pi, that means x tends to pi minus x less than pi, the function is given by lambda x. Right hand limit at x equal to pi, that means limit x tends to pi plus x greater than pi, the function is given by cos x is equal to value of the function, that is equal to f pi. What is the limit of this? Pi lambda. The limit of this cos pi is equal to minus 1 is equal to f pi fx equal to lambda x at x equal to pi, that is equal to lambda pi, which implies as lambda is equal to minus 1 by pi. So the value of is the value of lambda. Clear? Clear? Next question. If the function defined by this is continuous at x equal to 0, find the value of a. Function is continuous at x equal to 0. That means left hand limit of the function at x equal to 0 is equal to right hand limit of the function at x equal to 0 is equal to value of the function at x equal to 0. Fx is continuous at x equal to 0, which implies a left hand limit, that is limit x tends to 0 minus x less than 0. The function is defined by 1 minus cos 4x divided by s square is equal to right hand limit at x equal to 0, that is x tends to 0 plus x greater than 0. The function is defined by root x whole divided by root of 16 plus root x minus 4 is equal to value of the function at x equal to 0, that is f0. Here left hand limit of the function is equal to right hand limit of the function is equal to value of the function, which implies this limit x tends to 0 minus 1 minus cos 2 theta is equal to 2 sin square theta. Theta means 2x divided by s square is equal to limit x tends to 0 plus dividing root x in numerator and denominator, it gives 1 divided by root of 16 plus root x minus 4 divided by root x is equal to f0. f0 is equal to a. Clear? Which is same as limit x tends to 0 minus 2 into sin 2x divided by 2x whole square. 2 square, that is equal to 4 into 4 is equal to limit x tends to 0 plus 1 divided by 16 plus root x to the power half. 4 can be written as 16 to the power half whole divided by 16 plus root x minus 16. 16 can cancel, that is root x, which is equal to, which implies this limit x tends to, which implies this the limiting value is 2 into 1 square into 4 is equal to 1 divided by half into 16 to the power minus half is equal to a. Since limit x tends to 0, sin x by x is equal to 1 and limit x tends to a, x to the n minus a to the n divided by x minus a is equal to n into a to the n minus 1. x to the n minus a to the n divided by x minus a for, which implies this 8 is equal to 1 divided by 1 by 2 into 1 by 4 is equal to 8 is equal to 8 is equal to 8. Therefore, a is equal to 8 is the value of a. So that the function is continuous. Clear? Clear? Okay. Next question. Determine the value of k so that the function defined by is continuous at x equal to 0. Answer. fx is continuous at x equal to 0, which implies this limit x tends to 0 minus fx kx divided by x mod. That means left hand limit of the function, which is equal to right hand limit of the function 0 plus. That means x greater than 0. X greater than 0, the functional value is 3. Is equal to value of the function f0. Limit x tends to 0 minus kx divided by minus x. Since x tends to 0 minus implies x less than 0, x mod is equal to minus x. Value of the function, limit of this is value of the function at x equal to 0 also 3. K cancel is minus k can x's cancel minus k, limit of a constant is itself is equal to 3, which implies this k is equal to minus 3 is the answer. So that the function will be continuous at x equal to 0. Clear? Next question. Find the value of k for which the function defined by this is continuous at x equal to 0. Answer. fx is continuous at x equal to 0 means the left hand limit of the function at x equal to 0 is equal to right hand limit of the function at x equal to 0 is equal to value of the function at x equal to 0, which implies this limit x tends to 0 minus, that means x less than 0. The function is defined by root of 1 plus kx minus root of 1 minus kx whole divided by x is equal to right hand limit at x equal to 0. X tends to 0 plus, that means x greater than 0. X greater than 0, the function is defined by 2x plus 1 divided by x minus 1 is equal to value of the function at x equal to 0, that is f0, which implies this limit x tends to 0 minus 1 plus kx to the power half minus 1 minus kx to the power half whole divided by 1 plus kx minus 1 minus kx. 1 1 cancel, kx minus of 4 minus kx, that is 2kx, but the result is x, so it is 2k into 2k. 2kx into 2k, that is x. limit x tends to 0 plus 2x plus 1 divided by x minus 1. It is not in the indeterminate form. So the limiting value is equal to value of the function, that is x tends to 0 plus, which gives 0 plus 1 divided by 0 minus 1 is equal to f0. f0 is this, which implies this half of 1 minus limit x tends to 0 plus minus 1 minus kx to the power half minus 1 into 2k is equal to minus 1. Clear? Is equal to half of 1 to the power minus half into 2k is equal to minus 1. Since limit x tends to x to the n minus a to the n divided by x minus a is equal to n into a to the n minus 1. So 2 cancel, implies this k is equal to minus 1. Is the answer. Clear? Clear? Okay. Next question. Find the value of a and b so that the function defined by this is continuous. Answer: fx is continuous everywhere at x equal to 3 and x equal to 5. At x equal to 3, limit, left hand limit at x equal to 3 is equal to right hand limit at x equal to 3 is equal to value of the function at x equal to 3. X tends to 3 minus fx, x less than 3, the function is given by 1. Limit x tends to 3 plus right hand limit at x equal to 3. X greater than 3, greater than function is defined by x plus b is equal to value of the function f3. Limit of a constant is equal to constant, that is 1. It is not in the indeterminate form. Limiting value is the same as value of the function. So it is 3a plus b. F3 is equal to 1. It is equation 1. At x is equal to 5, limit x tends to 5 minus, that means x less than 5, x less than the function defined by x plus b is equal to right hand limit at x equal to 5, x tends to 5 plus, x greater than 5, the function is defined by 7 is equal to value of the function, that is f5, which implies this it is not in the indeterminate form. Limiting value is the same as the value of the function, so 5a plus b is equal to 7, that is equation 2. Limit of a constant is itself. Clear? equation 2 minus equation 1, which gives 5a minus 3a, that is 2a. BB cancel, 7 minus 1, that is equal to 6. A is equal to 3. A is equal to 3. B is equal to 1 minus 3 in 3a, which is equal to 1 minus 3 into 3, that is equal to minus 8. Therefore, A is equal to 3, B is equal to minus 8. So that the function defined by is continuous everywhere. That means continuous at x equal to 3 and 5. Clear?